Fusion 360 comes with a full CAM package which includes integrated milling, turning, mill turn, water jet, laser, and plasma cutting toolpath generation capabilities. Fusion 360 can program 2.5, 3, 4, and 5-axis milling machines to run the most versatile of machine shops. In this tutorial, you will learn how to create a setup, manage stock, create a facing operation, utilize adaptive clearing, and more. Now let's get started. So let's start this lesson by switching to the CAM workspace. Our first task will be to add a new tool, so let's open up our tool library. Fusion 360 has a fully customizable tool library that can tailor to the most flexible of machine shops. We can start off by creating a new tool library. Tool libraries can be used to organize tools while setting up CAM operations. Tools can be copied from the default libraries to have tools to start with while programming. Also, new tools can be started from scratch. We can specify the tool type, number of flutes, and different diameters and lengths to ensure our program is run correctly. We can choose to reuse this tool across any of our designs. Next, let's create a new setup to start programming our job. First, we will select the model which we want to start programming. Next, we will set up our working coordinate system by changing the orientation to select Z-axis and X-axis. Let's make sure the Z is facing up by selecting this edge. We will choose the pickup for our part in the corner of our stock. This is where we will probe our part. Now, we want to change the size of our stock. Let's go to the second tab and change the model to Relative Size Box. Then we can change the appropriate values to match the size of our physical stock. Now the exciting part. Let's start generating some toolpaths. We need to face our part, so let's go to the 2D toolpaths and select Face. There are 5 tabs in this dialog. These 5 tabs are consistent among all the toolpaths in Fusion 360. We will start by selecting a tool for this facing operation. In this case, let's select a 50mm face mill. Now we can hit OK, and Fusion 360 generates a preview of the toolpath to face the stock down to our part without any further input. Our next task is to start roughing out our part. Fusion 360's adaptive clearing strategy clears large quantities of material effectively. It is unique in that it guarantees a constant tool load at all stages of the machining cycle, which reduces tool wear. Again, we will start by selecting a tool. In this case, let's select an 8mm flat end mill. Then we will switch to the Geometry tab and select the edge of the extrusion. Make sure to click on the arrow so that the tool cuts to the outside of the geometry. Next, we will use the 2D contour toolpath to finish this contour. We will select a 6mm flat end mill for the tool. Then on the Geometry tab, we will select the same edge previously selected in the roughing operation. Fusion 360 possesses the industry's most complete set of finishing strategies, producing the highest quality of parts in a short amount of time. The last thing we always need to do is simulate our toolpaths before sending our program to the machine. So select the Setup folder and press Simulate. Let's turn on the stock and hit play. We can see exactly what our tool will cut prior to making costly mistakes. We can use the timeline at the bottom to jump ahead and re-watch the simulation. Now that we know that our tool will not produce a crash, let's create a setup sheet for our operator. Finally, let's post our program to our Haas mill. Fusion 360 has a large list of post processors to accommodate the most versatile machine shops. After posting, our code is open in brackets to view our G-code. You should now be comfortable with the CAM workspace and how to create a setup, toolpaths, simulate to avoid tools from crashing, and generate G-code. Go ahead, let the chips fly. Now click to learn more to get access to more CAM overviews, how-tos, and hands-on exercises.